And we're back. We are COMP305 in the fall 2019 semester at Centennial, or week 8, part 2 of our broadcast. We just finished talking about tile mapping, and let's talk about enemies a little bit. So I'm just going to remove the tile map, this tile palette, and put it away for now. And let's talk about what we have so far. So we have this really ugly tile set that I'm using. Again, moving around. You can jump. Double jump, but we don't have really any challenges. And what I'd like to do is to build an enemy that kind of runs around on this area right here, kind of patrols. I'm also going to take away this little bump that we have here, which is kind of weird. So I'm going to go to my tile map and then just erase that, because that's causing a bit of an issue. Notice I can't erase this stuff, and because this tile map is applied to the background, the only way I can erase it if I go to the super background, then I'm able to erase it. But then I can't erase this stuff. That's how it goes. So whatever you're pointing to, you can go in there and erase. Okay, but what we want to do is we want to add this enemy. And we have an enemy. We made one early on. Right? So again, if I go to prefabs, we have the enemy. Let's drag him in. So you can see we got this guy. He's like a little scarecrow, right? And I want to add a rigid body to him, and we have a collider, which is a capsule collider. Here it is, right? And let's add a rigid body. So we'll go rigid body, which is a rigid body 2D, so he'll fall. We already have a rigid body, yay. So we already have all that stuff. It should take into account, should kind of work. Let's just kind of make it work, and let me just check and see what the scene looks like. So you see he is kind of running. Okay, but we want him to start moving along the platform on his own. So what we want to do is first move him across. So how would I move him across? I don't want to change his position. I want to change his velocity. I want to control his velocity, right? One thing we know is we already have an enemy controller. So here's my enemy controller. And in order for me to change his velocity, I need access to his rigid body. So let's do that. So again, I'm just going to get rid of some of these spaces that I got in here. Just for now, we'll clean it up a little bit later. For now, it's going to be public rigid body 2D. And we'll call this the enemy rigid body. Let's make a connection to it. So again, the enemy rigid body is just this rigid body right here. There we go. And what I want to do is I want to add movement. So let's make a movement, a void move method, which we'll do on the player side later. And what the move method is going to do is do this. A, when I'm grounded, I want to be able to move. Oh man, wait, I need to detect when I'm grounded again. A couple ways to do that. I'm just going to use the same script we used for the player. So I'm going to go back to the player controller, and I want to get that is grounded script, which is this. And I want to kind of use this for how we detect ground on the enemy. So we're going to say, hey, is grounded, is this physics box cast for moving. If we're grounded, we can say that we are, and we want to kind of put together a public bool, which is grounded. That's this. All right. And if we're grounded, then we should be able to move to the left or right. But we need to know what direction we're facing. Okay? So, I mean, yes and no. I want to move towards the right if I'm facing right. If I'm facing left, I want to move towards the left. So by default, I want to, my public bool is facing right is going to be true. I'll make it true. Okay, by default, there it is. Again, I could put that in start. I'm going to say, well, okay, if is facing right and is grounded, those two conditions. And by the way, which one's more important to take care of first? Is grounded or is facing right? What do you think I want to check? If I'm not grounded, do I care if he's facing right or not? No. So therefore, is grounded is more important than is facing right if I'm grounded. And the only way I'm going to move is if I'm grounded anyway, so I'm going to put this first to skip all of the move actions. So I'm going to say if is facing right, then I want to move towards the right. I want to say that enemy rigid body 2D, right, dot velocity is equal to a new vector2 object, and I'm moving towards the right, which is some kind of speed. Let's put the speed up here. So again, public bool or public float. We'll call it movement speed. We'll say that that's going to be the x direction, movement speed, and we're not going to modify the y direction. So that's going to be 0. So that's going to be a direction. If we're facing right, great. If we're facing left, right, and I'm doing another if statement because it could be not facing anything, right or left, is if we're not facing right, then we're going to move a negative movement speed. Okay, so moving right, moving left. Pretty simple, but only if we're grounded. We're starting off as facing right, so we're going to start moving to the right. Okay, let's see what happens when we do that. So again, going back, we're going to go to the enemy. I'm going to look down to movement speed. Let's make it a movement speed of 5. Maybe that's too fast. Let's see what happens with this one. And if I press play, and we'll also pause for a second, let's see what happens to this guy here if we see him running. Is he moving? Is he grounded? No. Here we know that the background is ground. Here is this character, and he doesn't detect ground. So, is it because of where he is at? Right. Notice if I drop him, he drops. No problem. But he doesn't seem that he's grounded. And if I click grounded, he's still not moving. Right. So that's an issue. So one is he doesn't detect if he's grounded. We don't have any issues with him. Why? Because movement isn't in the update function. Right? Let's try that again. So again, we want to go to the enemy. This is a problem, right? Isn't that the same problem that he had before, like when we had the other guy? Well, of course he's going to have a problem because we didn't limit his rigid body. So he could fall over. So we want to freeze his rotation across the z-axis. Let's try that again. So again, we're going to pause for a second and move towards the scene. Bring the enemy in focus. Unpause. Go to the scene. Bring the enemy in focus. And watch him as he moves all the way up. Okay, he's going to get this all on his own. He's moving across. It's moving down. And then going to fall down. I don't want him to fall down there. I want him to go back the other way. So how would we be able to do that? Well, we kind of have our answer the last time. Remember the last time? We had this build where we kind of line cast down, right? We did a line cast. We have an initial position and we have a final position. Imagine if we can look downwards with our line. We're looking in front of us. So look forward kind of thing, right? When I'm looking forward, if there's no ground, if I can't detect the ground when I'm looking forward, turn around and go the other way. That's what I want to do. I have a little bit of code for this. So in our Centennial, we have a little bit of code from this morning's lesson that I used. I'm just going to steal that for now. I'm going to explain it, just so that way we just don't slow down, because we got a lot to cover still. So in the enemy controller, we have a code that we've seen before. We're going to call this has ground ahead, and I'm going to put this into place. So we detected if we're grounded. This is where we're detecting within. Now we want to detect if there's ground ahead. Let's do that one. So again, is there ground ahead? We called it has ground ahead. I'm going to make that another Boolean. So again, under is grounded, we'll make another Boolean. Has ground ahead. And has ground ahead is going to look at the line cast, and also we have this thing called look ahead. A look ahead is like actually a transform. So we're going to have this look ahead. So we're going to have a public transform called a look ahead, which takes care of this problem. Except we don't have a public transform called look ahead. So in our enemy, we don't have such a thing. Let's make one, just like we did on the player. See how the player has a ground target? I want to do the same thing. I want to pull this into here. We'll call this look ahead, which is just an empty transform. That's all it is. If I go to the enemy and go to look ahead, I'm just going to reset this one so it's relative to him. And what I want is for this look ahead to be slightly ahead and down. So it's going to go from the enemy, which is this point, to the look ahead, which is this point, in this diagonal line that's going to be drawn every single frame. Okay? And we're going to check, is there ground ahead? Is there ground ahead? Is there ground ahead? Turn back the other way. Flip this guy by using local scale, which means the look ahead will also flip over and then go the other way. So, okay, so here's the has grounded. We're going to check to see if we can see the in front transformed up position. We're going to see if between this transformed up position of the object and the look ahead position, if the layer in front is ground, then has ground ahead is true. All right. If this is false, right? If you're grounded and this is false, there's no more ground ahead for the enemy, right? Then what do I want to do? I want to switch facing. I want to say that I'm not facing right anymore, right? So if not has ground ahead, if not has ground ahead, then if that's true, I want to switch my local scale. So I'm going to say that transform dot local scale is equal to a new vector3 object where whatever my local scale is right now, transform dot local scale dot x, whatever that is, I want to take the other one, so negative of that one. So if it's 1, it'll be negative 1. If it's negative 1, it'll be 1. Right? And then the local scale for y is 1, and the local scale for z is also 1. So this is going to flip your scale if there's no more ground ahead. Right? Now again, this has to be if I'm already grounded. I'm not going to flip in the air. I'm only going to flip when there's no more ground. If there's no more ground, then I'm going to switch my facing. So I'm going to say that whatever my facing is, right, is facing right is equal to not is facing right, which means it's going to switch. It's going to toggle from one to the other. And this is going to come back around. When it comes back around to is facing right, if it's true, it's going to do movement to the right. If it's false, it's going to move movement to the left. Let's see if this works. So this is the test. The test is, does this line cast stuff work? So let's try this out. So run it. And let's go back to the enemy. Whoa. We have an unassigned reference. Oh yeah, the look ahead. Let's do that again. Alright, let's try this again. So run. And we'll go back to the enemy. And he's running. Remember, he's going to flip around if there's no ground ahead. Let's see if he's going to do it. So he runs. This is him by himself. So it's a simple enemy AI, right? He's going to do. He's going to run kind of down here. He's going to run. Oh, see that? He didn't go down the ramp. Guess what? There's no ground ahead. And he's going to keep going and stay up here. Look. Forever. Why is that? There's no ground ahead. He can go up to this point, but he's going to stay there. That's just the way he's been programmed, right? Now, we don't have anything like, I can't detect if there's a ramp. And also, I don't know, where my look ahead is. Let's take a look at my look ahead. My look ahead is kind of right here. This is what's happening. So he comes to the corner, and then, oop, there's no more ground. He's going to turn around. So what I want to do maybe is if I can set the ground a little lower. So again, let's suppose I move the look ahead down more, like this. Will that affect things? So again, let's go back to the enemy. Still not enough, right? Here's the look ahead. Look what happens. Still not enough for him to go down, right? How about if I move that look ahead even further down? Now this is dangerous to do this kind of stuff, but let's just try it. Yeah, now he's going to go down. So he's going to go down here, and then he's going to flip around, right? Remember, the look ahead is here, underneath the ground. So he's kind of scanning in front of him, but underneath the ground, right? As long as he's getting a hit, that there's ground there, he's going to be fine. Now he's going to go down. Look. Now he's going to wander down all the way, and he's going to go down to here. He's going to go to the edge and flip back. And he's going to keep going there all the way. He's going to patrol. Basically what he's doing, he's in patrol state, and he's going from one side of the platform all the way to the other. Look. See? All the way to here. Pretty cool. Very simple. Now, I know I need to make a change because my look ahead, these values I changed, right? So instead of me remembering what those values are, I'm in run mode. What I can do is I can go to here, to the little cog, and I can say copy component, right? And then I can stop everything. And then I can go back to the same component and say paste values. Done. So that's how you paste when it's running to when it's not. And that's why you use the editor. You use the editor so it helps you optimize your game a little bit more, right? Okay, cool. So we've got this thing. Now that I've got him working, my enemy, I'm going to override, apply all. And let's just make sure we did the same thing with the player because we made some changes to the player. There we go. So both the player and the enemy are now optimized. All right, they've been created properly. Let's just run this guy now and let's see what happens when the player goes and touches the enemy. All right. So again, the player is moving over and then he's going to jump. He's on there. He's running along. Yay! And then he comes to this part right here where he's up here, right? And he's running across. I'll just maximize the screen so we can make it more dramatic. And he's running down. And then, oh man, look what's going to happen to him. Is it enough for the enemy to push him up? In this case, it is. The enemy is going to push this guy all the way up. And this is the good thing. If you position the enemy properly, he'll literally dump the player back off the platform. In fact, even like jump on his head until he's down here. This is all using Rigidbody stuff, right? So now there's some issues. There's some issues with the enemy. The enemy is definitely you know, not positioned properly. Let's take a look at that. So we can see that if I unmaximize, let's go back to the enemy. And let's pause this guy a little bit. So here he is. Why is he above the ground? He shouldn't be above the ground like that. So this is another problem with our enemy. Well, remember, we made the enemy, but we never tested it. So what we want to do now is we want to go to the collider. Here's our capsule collider, and we can see what the problem is immediately. The capsule collider is way, way, way too high up. And what we want to do is we want to move this capsule collider down a little bit. Right? He's also a little bit too too much forward. Just a little bit, because if we go too crazy like that, and the reason why we want to kind of include him, sure, could we use a circle collider on the bottom and something on the top? We could, but this is about right, especially when he's falling. We want to kind of put this collider in there, right? And again, just like we did last time, the capsule collider, I want to capture the values. So I'm going to go here and go copy component. And then let's see what happens when I undo that enemy. What happens with him? Is it better? Is it worse? Is it the same? Does he look better? He looks better now. Look, he looks like he's running more on the ground. The ramp is a little weird, but then again, ramps are always weird. So, you know, he looks like he's running around the ground pretty good. And then he's going to jump a little bit. There we go. He's going to do that. He's going to fly, and then he's going to land. And he's going to continue to go down. So this looks pretty good. Let's just copy them back, the values. So I'm going to say paste values, right, which is what I want to do. Right here. Save them, override, and apply the colliders to the enemy. Now, why did I do all this? Well, obviously I want to make an enemy that's interesting, but also because you can have many enemies now. And again, example of this would be if I was to add another platform. Let's add another platform here. So again, going back to this, I'm looking at the background and I want to add another platform. So let's just do one of these. So this platform will be kind of somewhere down here, let's say. Maybe a bit of a drop, maybe a little bit more of a drop. So maybe it's down here. And I want to add this one, so we'll do one of these. So there we go. A platform that's kind of lower. Now, hey, be careful, because remember, in our hierarchy, we also have this death plane. Where is it? Can we see the death plane? Right now, the answer is no, we can't. So if I click on the death plane and I double click on it, you can see it's pretty large. If I turn on the sprite renderer, this is pretty much at the death plane, this lower thing. So that would be bad if I put it here, right? So we need to lower this death plane even more. And again, you can call it the death plane, the kill plane, whatever, but you got to lower this thing so there's a bit more of a fall. All right, give them a little bit of downward play for some of this stuff, right? Again, going back to the tile palette, we could make it so that there is a something like that with a bit of a platform like this, make it more interesting, right? Maybe a bit of some stairs so you can climb back up, right? There we go. Maybe he can make it there. I don't know. We'll see if he can make it back up. But the enemy will definitely not be able to make it back up. The enemy will stop. What happens if the enemy hits a wall? Right? So the enemy is going to hit a wall. What happens if he hits a wall? Well, we haven't programmed that. Right? We haven't programmed this kind of thing. What happens if the enemy hits the wall? We have no idea. That's the answer. He's going to keep on running towards the wall. So let's try this thing, and I'll show you this thing. Right? So this is where we have another condition. We have another condition where the enemy is going to hit the wall. He's going to come back to here and he's going to go this way. So let's put another enemy in play. So again, I'm going to go back to the prefabs and drop in an enemy. Here's my enemy. Right? And this enemy is going to go here, stop at the end, turn back and then get stuck. Let me show you what I'm talking about. So again, you can see that this is the case, and then you can see that this is guy's walking. He will turn. We programmed him to turn, right? But then once he gets to this thing, he doesn't know what to do, right? He's just going to keep walking. That's an issue, guys. That's a real issue. So he's got his look ahead, right? Now I need something else. I need the enemy to have something else called line of sight. So there's a couple ways we can do this. One, he already has his look ahead, okay? So if I kind of look at his look ahead, so if I look at his hierarchy, and if I look at this guy, I can see the look ahead is ahead. So he's got ground. He's grounded, but he's against the wall, right? That is an issue. So either I need another line in front of me to see what I'm bumping into. That's something I could do, right? That's okay. But if I'm that close, if I can use a line of sight where I'm going to bump into something, maybe I can use that line of sight to detect the player. Imagine I'm casting a line. It's invisible. If the line intersects with the player, right? Hey, that's cool. I've got something going on. However, if I don't and I intersect, and what I'm intersecting with is not the player, it's something else, like a block, turn around, go the other way. Right? Now, you still can get stuck with these instructions, but it may not be as bad. So how do we do this? So because he's kind of stuck here. He needs to turn around. So, all right, let's try and do that. So going back, has ground ahead. This is good. What about has wall ahead? How do we do that? And I can't use the same line cast because ground and wall are kind of the same, right? I need to position this a little differently. So it has wall ahead that I want to do. So I want to kind of make another one. Public bool has wall ahead, right? And just like we did this one, we want to make another line cast where if has wall ahead, if that's true, if he's bumping into the ground ahead of him, that means there's a wall in front of him, right? But the position of the look ahead, it's not the look ahead anymore, it's the ground ahead. Something else, another object, another instrument. So you can say public transform ground ahead. It's almost like the ground detector or another sensor. It's almost like another feeler. Think about this. This character now, this enemy has two feelers. One in front of him to see if he's got ground, right? One straight down, the box collider to see if he's grounded, right? One ahead of him if he's going to hit a wall, right? Which is going to happen now. It's called ground ahead. Alright, so let's detect ground ahead. So we're going to go back to this. Here's our enemy. And we can see that our enemy script also has ground ahead. We don't have such a thing, but we're going to make it by Control D. There it is, Control D. We're going to rename this to ground ahead. You can call it whatever you like. That makes sense to you. But this time, instead of the position that it's going to be here, it's going to physically be in front of him like this. So if he's ground ahead, let's say to there, something slightly in front of him, he's going to snap back and go the other way. And one thing to note is the the enemy and the ground ahead should be pretty much in front of each other. So enemy itself and the ground ahead. So we should probably put them on the same level. So the enemy position is at Y minus 1.555 and 132.73, and the ground ahead is 0.91 and negative 0.02. Maybe this could be just 0, which is the same level as his center point, his origin. He's looking ahead of him. And as long as this intersects with the wall, you've got wall ahead. Turn the other way. So, we're good. And by the way, maybe we can call this wall ahead instead of ground ahead. Maybe that's a better name. So we'll just rename this wall ahead. And we'll just call this wall ahead. Rename. So we can refactor, rename, wall ahead. Okay, so has wall ahead checks to look at the wall ahead position, right? And then when the wall ahead position is checked, we check to see if there's ground in front of you, and if there is, then has wall ahead is true. If not, has wall ahead is false. And if that's true, if we want to switch for both conditions, if not has ground ahead and if he does have a wall ahead, so or if he has a wall ahead, has wall ahead, switch. This will make him swap, turn around the other way and go the other way. Okay? So that's another condition we're going to add in to make the enemy a little bit more intelligent, but not much. He's still pretty dumb. The next one is, what if he sees the player? If he sees the player, he has a player ahead. If he's got the player ahead, guess what he's going to do? He's going to run after him. And he's going to pick up speed. He's going to run like twice as fast. His animation is going to change, you know, this kind of stuff. He can do that. Maybe he'll even jump when he gets close enough, right? He can do those kind of things because that's what the enemy can do. And if the enemy connects with the player, kills the player, let's just say, right? Or maybe he's going to fire something at the player. Maybe there's another animation you're going to have where you have an enemy that fires something. You actually go through his throwing animation at the player. Something like that. But for now, he's going to just chase. Let's see if that works. So we're going to go back and let's run it. Okay, I'm going to go back to the scene. And now, what the heck? So his look ahead is down here. And we've got an unassigned reference. Forgot to do that again. Which means his wall ahead is going to be here. Let's try that again one more time. Almost there. So again, the enemy kind of goes off. He hits the edge of the world and he turns around. Now he should bounce back now from the wall too. Take a look. So either one, whether he's on the wall or he's doing it, now he'll bounce around and he'll bounce wherever I put him. Cool? And he detects it. The enemy is using some kind of sight, if you will, by using line cast to do it. The line is in front of him. It's invisible. But it's got this line, right? We could even make it that if he's close to the player and if he detects the player, he jumps. He kind of does a jump. You know, he jumps straight up, you know, and moves forward at the same time. Something like that, where he kind of attacks or whatever, right? But for now, this is pretty good. So let's see what happens if we run the game and I am the player. What happens with the enemy? Does it push me off now? Does it look okay? What does it look like? So here I am with the little player. And again, I'm going to go here, jump. Oh, what happened to this guy? Well, what happened to this guy is we've got a null reference error because we didn't override the prefab. Right? Let's try that again. Again. Maximize. He's running. He's going to try and catch the enemy. The enemy is probably going up the hill here. There he is. Can I push the enemy? Kind of. Can I jump on the enemy's head? Not really. No. No. I can't get fast enough. Damn it, he's gonna knock me off. Okay, there we go. He's gonna go run up here, he's gonna run. Go down here, and then he's gonna kind of fall. There he is. Now this guy, now what happens here? Here's a case. I told you there's places where he can get stuck, right? No. So some problems solved, new problems created, right? What if he detects the player, right? Well, we know that if he hits the player, maybe our mechanic is going to be the player dies, right? So that's okay. We can figure that out. But now we have really the rudiments of some kind of player versus enemy kind of game, right? We have some simple AI. We don't have pathfinding necessarily. We could implement that with a grid, but we don't have that. But we have basic AI. Basic. I can see you kind of AI, right? One more thing here. What if we had some coins to collect, right? So I got some coins over here, maybe I got some coins over here, and I want to collect them. Well, do I have a coin? I do. I have these coins here. And I could include these coins inside of a coin. If I go to multiple and I apply, I could go to my sprite editor and I can see these as coins, and I could do that for sure. I could do that if I want. Or, since I already have all of this, I might as well just use it. So I want to make a coin. And I'm going to take all this stuff, make a simple animation. So this is the coin animator. Again, I'm going to go into Assets, Animations. We're going to make a new folder called Coin. Inside here, I'm going to call this the Coin Animator. Coin Animator. And if we go in there, under Animations, and here's the coin, we can see we've got two things. Actually the coin, this is the coin clip. Coin idle, or coin spinning, if you will. Here's the coin spinning, and then we also have the coin itself, the coin animator. Coin animator. And we have the coin object. Here's coin. Might as well name it coin, so we'll tag it in as a coin. So go to add tag, add a new one, call it coin. These are all things you should have known how to do already. But let's just rename it as coin. There we go. We're creating this prefab, right? So where is this thing? Well, we added it way down in here, but we want to add it so the player can see it. Let's add it over here. And what we're going to do with the coin is add a rigid body and a collider. So again, I want to add a rigid body 2D to the coin. And I also want to add, one thing I don't want to do is I don't want it to flip. I don't want it to rotate on the z-axis. I want to stay where it is. And I also want to add a collider. So is a box collider good enough in this case? I mean, kind of. You know, who cares? I would say. But if you really want to be a stickler, as an example, then you could use a circle collider, no problem. So let's add a circle collider. And you can see that it's a little better. That's fine. Because it's going to rotate to be that big anyway. But what happens when it gets really small? We can't change the collider over and over again. It's always going to be the same size. Who cares? Let's see what happens. So if I run this thing, it kind of drops and spins. There's my little coin. That looks really small for him. Maybe you want to make the coin bigger, right? Let's do that. Let's get the coin going bigger. So, I mean, again, how would you do this? A couple ways. One way to do it would be to we could change the scale of the coin right now. So we can go scale 2, and that would make it twice the scale. And of course, so would the collider. So that's one way of doing it. We could also change the actual object. And you can see now that it kind of spins around like this. It's a 2D animation that makes it look like it's 3D. It's very simple. And what I want to do is I want to collide with the coin, pick it up, get points, make coin sound, all that kind of stuff. Make this coin disappear. Okay. So the other thing I could do is I can make this coin bounce. So I can make the coin always be bouncy. So what I could do is in my physics material, we have materials. My default physics material has no bounciness. Let's make another one. So create a coin material. So again, it's going to be a physics material that we want. And we want to call this the coin material, coin physics material. And the coin physics material is going to be, friction is going to be 0. It's going to slide all over the place when it drops. And the bounciness is going to be, well, I'll make it pretty good. How about 0.6? Let's see how that looks. One thing we have to do is just rerun it and attach it to the coin. So we're going to go to the coin, attach this physics material to the coin, and then try it. Right, so kind of a bounce. If you want it better than that, like we don't think that's good enough, we could definitely make it bounce more, but be warned that the higher you make it bounce, then it could bounce forever. Like this is 80% efficient in terms of bounciness. Right, so again, I can kind of go forward and kick it so it goes off the screen. Right, watch. So, boom. Play with the coin. Right, it can bounce around. We don't want that. We want when the hero touches the coin, then it disappears. We get points. Okay, so again, just like before, we want to make the coin a prefab. So I'm going to go back to the coin or the prefabs folder, and I'm going to make the prefab coin a prefab by dragging and dropping. There it is for now. So here's a coin. Let's add a couple more, just so we can hear the coin sound a little bit more. So there we go. So there's some more coins that they're all going to land. This one will land one on top of the other one. Let's see what happens when we do this. We should test it out because we don't know what it's going to look like. Right? Let's try it again. So it looks more realistic, but really it's only a 2D object. So just flipping around makes it look like it's 3D, but it's not. So it looks pretty good. I wanted to test out what happens if in this case. I'm not going to do it right now. So now what I'm going to do is let's collide. So how does the player collide? Again, we're going to go to the player. We're going to go to the player controller script. And this is the first time we're doing an on collision enter 2D. We've never really cared about that so far. Again, you notice that on update, all of this stuff is happening for the player. And this is all movement stuff. I should put all this, encapsulate this in a movement function. So again, I'm just going to highlight all this stuff here, all the way down to the end of jump, this part. And now what hopefully we can do is we can right click and we can go to refactor. I want to extract a method. And what this is going to do is going to say, okay, what method do I want to use for this? Extract method. I want to call the method move. And what it does is it makes a move method going here, and it makes a separate method right here. So I can collapse this method now. It's my move method. Collapsing is really cool because you can organize your code a little bit when we do that. So what I want to do now is I want to have a function to check on collision enter. So on collision enter 2D, we want a collision 2D with something else, and if that other if that's equal to coin, if that's equal to coin, so I'm saying, hey, if my other game object tag is equal to coin, right? By the way, you can also use compare tag name. So if other.gameObject, and by the way, you can do that, compare tag with, which is much better than is equal to, with coin. That is a better way of doing it. Other.gameObject compare tag coin. If that is true, then I know I've hit a coin. What I want to just do is destroy my coin. But before I want to do that, I want to make a sound, the coin sound. So now, going back to you guys, should the coin sound be part of the coin, or should the coin sound be part of the hero? Now, there's pros and cons about this. If the coin sound's part of the coin, then we destroy the coin still has to make a sound. So either you run it in a coroutine and wait for the coin sound to be finished before we destroy the coin, or forget that, right? Teleport the coin somewhere else. Don't even destroy the coin. Just move it off screen somewhere and make a sound, right? Or make the sound that the hero has inside of him, that he contains the coin sound. The hero object contains the coin sound, and then, you know, kill the coin. So it's really up to you what you want to do. But here what we want to do is if we had a scoreboard, we would update the scoreboard here. I'm not going to do that here because I'm running out of time. I want to do other things. Update the scoreboard, you know, example, add points, right, for the coin. But we also make a sound. So if you want to do the sound, let's do that. We want to destroy the other things. We want to destroy the other .game object. That's what you want to do. So the object is gone. Every time we hit it, it's finished. But we also want to make a coin sound, and one of the easiest ways to do that is just add it to the hero. It's not the only way, it's not the best way, it's a way. Alright? We know that the hero has an audio source already. The first audio source is the jump sound. Okay? So what he's doing is he's saying, hey, I've got this jump sound, it's an audio source. Again, the cheesiest way to do that is to just drag and drop another audio source in there. So let's just do that. So double click. And again, prototyping, it's okay to do this. Later on, there's other things we need to do that to make it better. So I want to make a coin sound. And just like we said before, the audio source, instead of a jump sound, we also have a public audio source that is the coin sound. And you know what might be good is if we took these two things and we created a new header on the inspector. So sounds. Okay. Just bundling these things together here. If we go back to the inspector, we should see on the player, it should be organized into the player audio sound as well as, let's add another audio source. Here's the other audio source, and this audio source is going to be the coin sound. So again, I'm going to go to audio, I'm going to go to coin and drag and drop it in there. I'm not going to play on awake. That doesn't make any sense. But I will drag and drop this coin sound into the other slot. There we go. Save. I'm also going to apply that. Change. So now we have our coin sound. And what I want to do is I want to just play that coin sound before I destroy it. So I'm going to say coin sound dot play. Oops. There we go. And then destroy the other object. For now, we should have updated our scoreboard as well. But we don't have a scoreboard right now. Alright, let's try and see if that works. So, right, got the sound, got the coins happening. Now there's a bit of a delay. Did you see that? Let's see what happens here. Watch. See how he pauses? Why is he pausing? Two things are happening. They're taking up a lot of memory. One, destroy. Destroy is actually memory intensive because it actually frees up memory. That's what happens. The other thing is the rigid body takes hold too. Just for moments. Look. He's not quite moving at the right speed and he does destroy the coin. Right? So one thing we could do instead of a rigid body being taken to place and this collision is on collision enter, on trigger enter. So his collider is more of a trigger, not a collision where he's actually running into the object. He can pass through the object and it won't stop his speed. Right? So again, going back to this, instead of on collision enter 2D, we can change this to on trigger enter 2D. There we go. And now this is tricky. We're going to say that it's a collider 2D. Everything else remains the same. So we collide, we trigger, on trigger enter, we kill it. But the challenge is where, with the player, where do we have this happen? Is it the rigid body that happens? So here's the rigid body. Is it the collider? Do we have to have another collider? Because remember, our collider is not, our capsule collider is a good example. Here's our capsule collider. Is not a trigger. Our capsule collider is a collider, right? So what about the coin? Maybe the coin is the one. So if I look at the coin doesn't really have anything but this, the circle collider. Let's make this the trigger. Will that trigger my collider? This is where we run into some thoughts, right? We have to think about this a little bit, right? So a couple things have to happen here. One, first, let's see if this works. So we've set it up, and by the way, one thing we didn't do is we didn't override the prefab. Let's do the prefab. Apply to all of them. Let's do it again. So again, we have our stuff, and now they fall into oblivion. And of course they would, because no good, right? Cool. So that can't be. So the coin idea where we have the coin using a trigger collider or whatever, that's not going to happen, at least not this way. Alright, so we've got now back to our player. So that's not possible, but what about our player? We can't really turn off the capsule collider for the same reason. Can we have another collider? Yes. Right? We can have as many colliders as we want. We got to be careful though for the choice we want, right? So again, if I want to physically collide, I can do that, but if I want to make this a trigger, I'm going to fall through the ground. So I could have another one. So let's add another collider. What are the other options? So I've talked about trigger collider, I've talked about, you know, these things. What can I do? What else can I do? I could set up another ray, right? March along, I hit with the ray, I hit the coin, gone. I could do that. Rays are expensive, so you want to do them for really good reasons. Let's make another collider happen. So another collider. Let's make it a circle collider. Oh, if I can spell circle. So the circle collider 2D, this one will be a trigger, right? So you can have two. You can have one that's a physical collider that does, we'll move this up. No, we're not going to break the prefab. We'll just add a circle collider and call it a day for now. Yeah, so here's our circle collider. Now we can kind of do both. We can do a physical collider, which stops us from falling through the ground, and we can do a circle collider, and if you notice the circle collider here is around the player. As long as the circle collider connects, we don't care. It's just, it could even be a box collider. I mean, really, it doesn't matter what kind of collider. You just want to interface with this shape right here. Okay? So now it should work. Let's try it. So again, running, and then we're good to go, right? And now this time there is no pause. See? I don't have any kind of thing going on. I go right through. Why? Because I'm using a circle collider for that part, and the rest is normal. Also, the other thing you want to do is this. Should the enemies collide with the coins? Should the enemies collide with the coins? The answer is no. So if we have enemies and coins together in the same place, then theoretically the enemy should just go right through the coin and not collide at all. How do we do that? This guy's going to knock me off now. It doesn't like me. Right? Right? Here I am again. So if the enemies collide with the coins, how do we do that? Well, there is something we can do. So under File, if we go to Build Settings, and if we go to Player Settings, There's one way to get there, by the way. The other way to go is to project settings. Under this, we have physics 2D. Notice this. Ground. Water. So we have ground and ground. Ground and ground can collide. We have all the default stuff colliding with everything else. We can make our own, and we can use this little grid to decide what collides with what has physics on something else. Let's try and see if that can work. So the way we do it is we create another layer for the coin. So the coin itself, instead of being on the default layer, we can make a new layer, the coin layer. Add coin. And I want to show you how this works. So here's the coin, right? So if I don't want the coin to collide with the ground, and I want it to go right through the ground, I can go, again, I can go back to Edit. In this case, I'll do Project Settings, and I'll go to Physics 2D. And underneath there, you can see that coin and ground, no collision. Right? Coin and ground. Coin, ground, and coin doesn't matter, but coin and ground does. Coin and ground. Ground can't connect with, and then how about coin and coin? Should coins collide with each other, or should coins pass through each other? I think coins should collide with each other. They should kind of push each other around. But coin and ground, let's say pass it through it. Let's see what happens. See if this even works. So what I'm expecting to do is these coins are going to pass right through. Let's see if that happens. Nope. Hey, even give me some. See, give me some points. So again, assets, so edit, project settings, right? And then we have coin and ground. Well, why is that? Because we made the layer, but we never assigned it. So if I go to coin, here's a layer. We can assign it to coin and then hit apply all. Now it's part of the coin layer. Coins are part of the coin layer, and they're also tagged as coin, right? So now if I look at it, if I run it, watch. They go through. So they ignore physics. You can make certain things collide and certain things not collide. Example, the coins will not collide in this case with the ground. We want the coins to collide with the ground, but we don't want the coins colliding with the enemy. So we can do that. So we can say, let's put the enemy on an enemy layer. So overrides, layer, add a layer. We'll make an enemy layer. There we go. Here's the enemy layer. And of course we need to assign the enemy layer. Yes, change children. And we want to override everything so that all enemies are part of the enemy layer. If that makes sense. And now that we have all enemies part of the enemy layer, we want to go back to Edit, Project Settings, and we want to go down to this physics area. We want to say that coins, well, they don't collide with enemies. So enemy and coin don't work. They don't collide. Enemies pass right through coins. Right? Coins hit the ground, no problem. Coins hit each other. Coins hit the player. Coins would hit water if there's such a thing. But coins and enemies, they don't hit each other. So the way it works is, if I take a coin and put it over here next to the tree, just to show you this, to prove it to you. So again, here's the coin, and put this right here. Let's put a few coins there, like in a row. Maybe some of them high, some of them low. There we go, like this. And if I was to run this thing now, I can collect them, right? And let's go run over here, and you can see right here there's a bunch of coins sitting here waiting for me because they didn't hit the enemy. The enemy passed through them. Okay? And we can watch it happen. If we wait long enough, the enemy is going to make his way all the way down to the other end and back. Right? And then when he comes back, right, let's see if I can push us in there. Is he coming back yet? Yeah, there he is. He's running at me now. And if I jump, that was cool. He runs right through them. But me, no. He killed, oh, I almost died there. So, climbed up, and then me, I can run into the coins, no problem, and pick them up because I'm part of the layer that collides with coins, but the enemy is not. And this can present different options for us, right? Because we can have certain things, example, certain areas in the grid on our map that are non-collidable. They have a different layer that they're part of. But meanwhile, so the enemies pass through them, but we have to collide with them. The enemies could go right through the wall, but not us. For example, enemies that are ghosts, or enemies that have different values, or whatever, or some kind of trap that would work on us, right? But wouldn't work on the enemy. Enemy would be avoided, would be ignored, but the trap would kill us, right? So these are kind of things that we can do. Alright, so this is all fine and good, but I've asked you guys to put your stuff up on live somewhere. How do we do that? First, let's save our project. Again, it's far from complete. We've got some elements that are starting to work now. We're not even quite at an alpha stage yet, or even a first playable. We don't have any kind of user interface. We're not there yet, but we're getting closer. So let's save the game, or save the project. One thing also is, I really don't like this. I'm not a fan of this at all, right? So again, what I would recommend highly is that you create separators. So I want to make something called coins. Again, I'm going to go to create empty. We'll call this coins. So all the coins are in the same empty prefab. Take all this stuff and then just put it inside there, if I can do it.
One coin, will they all disappear still, or?
No.
Okay,
no. All this does is it organizes it so they're all together in one thing. So if you want to see how that looks, it looks like this. They don't have the same collider. They're just organized so that in your hierarchy they're not polluted, right? Same thing with the enemy. If I want to make all enemies in one, I can make an empty, and I'll call this enemies, right? And then I take all the enemies and put them inside there too, right? So I'm organizing my project so I have coins and enemies. And one good thing about the enemies is I could move them all if I want to, or I could hide them all. Like if I uncheck this, they all disappear. That is a really cool thing. So I can check levels that have coins or don't have coins. I can check their position. I can take them away. This is all good control for you from a check perspective. Also, you know what? We have one checkpoint. I would love to have another checkpoint. I mean, my guy would die here and he'll reappear, but what if he dies over here? Maybe there should be a checkpoint here. And if I reach this checkpoint, then that would be the active checkpoint, not this one, right? So that might be something I want to implement as well. How do I do that? An array of checkpoints. I have all these checkpoints. When I pass by a checkpoint, it has a trigger collider. As soon as I pass by it, it connects with me. I activate the trigger, it becomes the active checkpoint. The next one, if I pass by, it becomes the active checkpoint. And only the active checkpoint is the one that I want to go to, not the other ones. Right? Make sense? But for now, let's save the game. So we're saving it. Good. We have a good format. And what I want to do is I want to close off Unity before we're saving it. And I want to put it up on GitHub first. So again, I'm going to go back here. Here's my Unity project. And I'm going to say git add dot, git commit -m, and I'll say added enemy or simple enemy AI. Git push origin master, which will push everything up to GitHub, and now you'll be able to, have everything that we just did. So all the code that I just put up on GitHub under lesson 5b. You guys good to go. Now, one thing I need to do is I want to use something called Github Pages. So here's Github Pages. It explains how to use the free web pages that are provided for you by GitHub. Okay? There's no cost whatsoever. You can host any project that doesn't have a back end. So if you want to have an Angular project with, something like Node on the back end, that's probably not going to work. You need a server for that. But if you're going to have an Angular project with no Node and it's just Angular on the front end, yeah, totally, this will work. And it's really, really cool the way it works. There's a little video on how it works, but basically what it is all you need to do is you need to point if you have your own site, it's GitHub .io, whatever your username is, .github.io, you make your own a repository that looks like this. So in my case, if my repository is called Sliopoulos, it'd be sliopoulos.github.io. That's what the repository name would be. And then anyone that visits my site, if you will, this link, it'll just show them a web page. Let me show you how to do it another way. So I want to do this for my page, but I only have, if you notice, I only have these different repos. Look at, I made this one called Lesson 5 Build. I'm going to do the same thing with Lesson 5B Build, right? I'm making a separate builds folder. Remember what I told you before, that I want your gitignore file to ignore the builds folder. Again, I'm going to go back to here, and let's make a build. Now, remember we talked about this. WebGL build takes 5 to 10 minutes, depending on your system. Okay? So I want to take this, and I want to run it on the web. Now, caution. Just because it worked in your editor does not mean it's going to work in a build. Okay? It doesn't matter if it's built for PC, Xbox, whatever. Right? It may not work. So let's do that. So again, File, Build, Settings. Notice that the main file that's going to be built is this main scene. Right? So far I'm targeting PC, Mac, Linux. I want to move to WebGL. Now, in order for you to do this, you have to have downloaded this component when you downloaded and installed Unity. Or you can go back into Unity Hub and reinstall this component. I want to switch platforms. That's going to take a bit of time first. So I'm switching platforms from PC, Mac, and Linux to WebGL. And it's going to reconvert some stuff or whatever, change certain shaders, and now we're good. We've changed. But now, let's go to player settings. Player settings show a couple things. My player says, my company name is default company. Please change this to something else. If you have your own name for your squad, your group, call it that. In my case, it's going to be Centennial College. This lesson is fine. Version number is fine. This I want to change to 800 by 600. That's just my personal choice. So that's going to be the scale I'm using. And that's it. That's what I want to do first. So first I change my player settings. Cool. Now that I've changed my build to this, I can do build and run. Build and run will ask me where I want it to go. I want it to send it to another folder. I'm going to make a new folder called builds. By the way, by default, GitHub, for now, our gitignore file ignores the builds folder, so it won't actually upload this to GitHub. But we're going to change that in a sec. Alright, so you're saving, and then hopefully if this null reference error is fake, which it looks like it is, it's going to continue to build our project, and this could take, like I said, anywhere between 5 and 10 minutes, depending on your machine. So hang tight as this happens. And why is this? Because what it's doing, again, and I talked about this in the day during the class in the first session, right? Unity does two things. Unity, there's two sides of Unity. There's the nice side and there's the dragon, right? The nice side of Unity is C#. You see C#. The dragon is the native side, and that's C++. So on the back end of Unity, you always have C++ running. And what's going to happen here is it's going to convert using your scripts from C# into C++, then transfer it into WebAssembly, which is kind of a newer thing for the web. Transfers into WebAssembly. We're going to wrap it up with an index.html and some JavaScript files, and then we're going to run this WebAssembly enabled file on the web. And it's going to be, hopefully, perfect. It'll look good, it'll support controllers, it'll do the whole thing. Why? Because it's being bundled and it's running in WebAssembly. Now, they did it in different ways before, and they used pure WebGL. Nowadays, they don't just use pure WebGL. It's actually using a very, very efficient way of doing things. WebAssembly is the new way of doing stuff. It's kind of an emerging tech that's been out for a while, and Unity has kind of implemented it over the last couple of versions. So I think it's been around since 2017 or earlier, WebAssembly. But basically, it's been around for years. So let's try this out. So here, where it says building native binary with IL2 CPP, right? So it's and here we go. It's compiling to WebAssembly right now. So it has different process time for all this kind of stuff. And once it's finished, it's going to launch a web page, and we're going to get a preview of what this looks like locally. Again, guys and girls, this may break. We don't know, because a build is a build, and the editor is the editor. Always remember that. It doesn't matter whether you're building a 2D game, a 3D game, or a VR game. You need to test it in both the build and in the editor side. Sometimes the build on a PC will fail. Sometimes the build in Android works. Could be the same thing, as a good example. And remember, Unity has the ability for you to do cross-platform development. So you can develop on a mobile device, Android or iOS device. For the iOS device, unfortunately, you need a Mac right now. But you can develop for Android, you can develop for PC, you can develop for the web. There's lots of opportunities. If you have the SDK for Xbox, which is a special thing you can get to by signing up for ID at Xbox. If you're a developer, you can do that. Or the PS4 SDK, which by the way costs like $1,200, right? Good luck to you, right? But yeah, you could actually deploy it to a PS4 as well. So all that is possible with Unity. And as you can see, I'm talking this through, but it's taking quite a little time. So in the video, when you're watching this, just fast forward, because it's going to be like 2 seconds. You won't have to see this anymore. But as you can see, it's taking quite a little time. And again, specs-wise, my machine is pretty good. i9, 32 gigabytes of RAM, NVIDIA 1080. I don't think I got slowdowns for now, right? I mean, it's not the latest, it's not the hottest machine. Now the hottest machine is an RTX 2080. Oh, sorry. Yeah, right? RTX 2080. And the new ones have like a Tobii eye tracker and everything else. That's the new beast. This is the old beast, okay? But it's still a beast. So if it's slow like this, can you imagine what your machine's going to look like or feel? It's going to take a while. So be careful. Don't try and plan for WebGL builds at the last minute. Like if you're going to do this and hand it in, like 5 minutes to midnight, you're going to be late, as you can see. Right? So plan for your build. Okay, it says compressing, finishing, and deploying. Here we go. And without further ado, we have a website. Yes? Yes. And that's actually on a web page. So you can see that I still have that. Ah, I failed. I died. And now he's going to reset. So this is on a web page. So all the same stuff looks like perfect. Really, I'm using a controller and everything, right? Right? And pretty much everything is working well. Again, the same crappy graphics that we had on the PC build, but which is good. It means consistency, right? Oh, no, wait. What? I'm being pushed, and I can't. Oh, I can't. I feel like a. Oh, that's interesting. Oh, that was I almost broke it somehow. Oh, oh no. Okay. Okay. So as you can tell, this works. This is a good first step. So the next step that we have to take is, hey, let's get this build up on GitHub. So how do we do that? Well, let's save this again and let's get out of here. And this is what you do, guys. So remember that Lesson 5B has a build folder, right? The builds folder can have its own GitHub link. It can have its own Git repository that has nothing to do with the rest of the project. So here I'm going to change directories to this. CD to the new build. So here we are. So we're into the builds folder. Here we are. And now I want to do the same things that I did before. Git init, which initializes the Git repository. Git add dot. It adds all the stuff we just did. Git commit -m initial commit, which does everything we need to. Now we need a repository for it to go to. And I'm going to go back online and I'll make a new repository. And this time I'm going to call it, just for us, in the right organization, COMP305, and it's fall 2019. It's lesson 5B build. Actually, I'll put an underscore, build. There we go. Yay. And I need just these 2 lines of code right here. and right click and go, and you're going to see that it's going to go up to GitHub, 6.5 megs, right? Now this is why we need to do this, because your GitHub repo, for you to host the site, you must have your index.html front and center. It cannot be buried inside of another folder. So it's got to be like the root of the folder, just like normal, and when you're hosting it on a server. Okay, but we're not done yet. What we need to do is go into settings, and this is the part that you need for your final project plus your projects that you're doing, individual assignments and so on. If you scroll down, there's an area that says GitHub Pages. All you need to do is change this from none to master branch. And then it needs a couple seconds to propagate, and it's going to give you a link like this. And this link, my friends, should run, and again, it takes a couple seconds, so give it a sec. It should run your pages. And the reason why sometimes it does this funky thing that it's doing is, by the way, just to show you something, here's my code. And if you look at my commit, you can see that there's this little check mark here. This little check mark basically says that GitHub Pages should be active. And you can see that it says pages build, GitHub Pages is running, right? And you can see the builds. This is the actual GitHub page. Now, I'm guessing that this is still propagating. And if I run it in another browser, like, for example, Firefox. Let's run Firefox and see if we can actually see it. No, I don't want to use Firefox as a default browser. I use Firefox so that way it doesn't have anything. So sometimes it does this. And this happens, guys, like it really does. Remember, here's the thing, that you have to keep in mind. GitHub Pages is free, right? So it's a little bit temperamental at times, and that's the way it is. So if I'm going to go down to settings, and I can uncheck that box and recheck it. Sometimes that works. It says green, right? So what it's supposed to do is go here and work, but sometimes it doesn't. So we can go back off the master branch to say none, which is going to uncheck that box, and we can try it again. It'll try and do a rebuild of what we just did. So master branch. And you have to wait. Until this site becomes green, and again we can refresh. But it takes a few minutes. It takes a few minutes because it needs to propagate, right? And if it doesn't propagate, it doesn't matter what you do here, it won't work. There we go. And now you can see that it's live. So why don't you go try this out, guys? You should be able to access it. Now go ahead. centennialcollege.github.io/COMP305 F2019 lesson 5B build. You should be able to access it from this link. And this is what I want you guys to do for your assignments going forward and for your project. Right, your final project, each of your builds going forward should have a live link. Why is that? Well, I got a selfish reason for it. It makes marking super easy, right? Because then I can just run your project online and, hey, look, it's working, right? And there's a really good reason for you to have it. If you're someone who's going to go to an interview and wants to show your stuff, you can have these projects running, and they're perfect. You can run it off any web browser, right? And it should run because Unity is compatible with any web browser. There you go. So some people are using it already. Not perfect, not foolproof, and definitely breakable. But this version of the project is ready to go. And again, we can access it live on the internet anywhere in the world, at least for now until I shut it off. There you go. Okay. So that is the way you put up your stuff up live. Any questions around that? One of the questions I had before was, is there a limit? How many GitHub pages can you make? And the answer is really none. There's no limit that I've seen. The only thing that you got to be cognizant of is if you have a back end, like some kind of file access, if you have something like JSON access or something like that, or any kind of database, sometimes it doesn't work, right? So especially on database, there is no database engine, there is no node engine, run, you know, on this thing. It's very simple. If you want to run a very simple page, you're good to go. If you're running some kind of crazy, you know, advanced server or something like that, then you're going to be in trouble. It won't work properly the way you think. My little guy, he's working on GitHub. Alright, so pretty cool. I like that kind of thing. So we've covered, just to recap, I'm just going to bring back Unity Hub for now. So we've covered a couple things. We've covered, just to recap, how to do tile mapping. Very basic. There's more, by the way. Tile mapping is, what I've covered right now is like the basic part of tile mapping, right? One thing you should try and do is find some good, if you're gonna use tile maps, find some good tile sets that you can use. Again, you could definitely go up on online, as an example, to go to OpenGameArt. I think OpenGameArt is a good place to get some cool, you know, 2D and some 3D assets for free. A lot of these guys and girls who contribute to OpenGameArt, all they want you to do is give them a you know, kind of a credit that they work, that, you know, they use their stuff in. Here's one, look, platformer. What is here? Platformer pack 16 by 16. Perfect. Look, they made enemies, bullets, players, different kinds of animations, right? I mean, there's tons of stuff, and some of it's pretty funny actually. The way they've done, they use pixel art for this stuff. They also have music. For music, we talked about this before, but I'll talk about it again. Please don't forget bfxr.net. So if you look at bfxr. bfxr.net is a Flash-based editor where you can make your own little sounds for free. So, for example, I can go make a laser shot or an explosion, and you can modify those things, right? And then play it, and maybe no, it's not going to play anymore because I broke it. And maybe do something else. Okay, there's a jump sound. So these are very basic things, and you can download them as WAV files. Or the one I like even more, and I put these links up on eCentennial for you. The ones I love even more is Chiptone. So I may have showed you this before. Did I show you this before? Chiptone, pretty much better. A sound generator. So again, I want to make a boom, and then I want to make it vibrate, right? Or I want to make some harmony, you know, and I can make it different sounds. Sometimes it's good to vary sounds, so you can download different versions, like, right? So it sounds like you're hitting multiple times. It's boring to hear the same sound over and over again, like that sound that we just made for coins. You know, it's the same sound all the time, so it's enough to kill you with boredom, right? But if you make different variations on sounds, that can really be helpful, and it's easy to make something like that here, right? But they have a lot of different ones, and you can combine them. There's a lot of filters you can combine. And again, this is all for free. Here's Tremolo, right? So, I don't know if that makes sense, but you can make your own kind of sounds, which is cool, and then you can download them, save them as a WAV file. So kind of cool.
So sir,
yeah.
On your build, would you use Chrome to run it or Firefox?
Chrome.
So what browser are you using to test our game? Because my Chrome testing your game is fun, but testing his game or your game on his Chrome is like, you're like floating and it's not right. So like when you test our game individually, like how would that affect our grade?
Well, I'm going to look at both things. I want to take a look at stuff. I recommend you test your game. And I want to see what he's seeing on his Chrome. If it's really bad.
Like left or right, he's like topic skipping, I guess.
Okay, I'll take a look at it. I'll come over.
The same browser, it's fine on mine. So I'm not sure.
But what version of the browser? Like, you remember, if you've got an older version of your browser, then it's going to appear differently, right? Yeah, there's going to be an update on the top right. There'll be an update for Chrome, but mine doesn't have it, so yeah. I'm using the latest version. So yeah, it should work on Chrome the same way. And I would test it. Test it on Chrome, test it on Firefox, see how it works. So let's test it on Firefox. So if I was going to test this on Firefox, And let's go back there and test it. So GitHub.
Oh, that's why they updated.
So if I go back to the builds, and I go back to, settings, see it's nice and green, and there it is, right? So you can see this is the game. Let's test this thing on another browser. Let's test it on Firefox. Not Fireworks, Firefox. There we go. Firefox. No, I don't want to convert ever. That's not true. Firefox is pretty cool. This is Firefox, so that'll work the same. And you can see almost the randomness is almost the same too, right? So there you go. And then you can see that I can run. It's pretty good on Firefox too. But I would test it on both, and then if you find more success with Firefox over Chrome, say, sir, you know what? Works great on Firefox. Chrome is buggy. I'm fine with that. I'll just take whatever it is, because you know what? It's a build thing. And there might be something that's a little different on the Firefox side. Chances are not, right? Safari is a little weird. If you try and run it on Safari, or even on IE, Edge, yeah, that might be weird, right? But for the most part, on Chrome, it works okay, and on Firefox, it works very similarly, right? One thing I did want to show you was what the build looks like physically. So under builds, you can see what you get, right? You get this index.html page, which is the wrapper for everything else. And in your template data, you have all this stuff. It's basically your Unity progress bar, that's what it is, and some stuff to make the web page look okay. Then inside your build itself, this is where you have your JSON data, your JavaScript wrapper, as well as your WebAssembly. And what happens is your Unity loader.js is being called by your index.html. So if you look at your index.html with something like Visual Studio Code, you can see that it's doing a couple things. It's loading up the progress bar, it's using a style sheet for template data, and using the Unity loader.js. Unity loader.js, which is here, is this. Now you're like, wait, what the? It's just compressed. It's a minified file that allows you to, it basically wraps up your code, and it looks really ugly, but at the end of the day, it's using SVG for some of the graphics files that we're using. It converts stuff into something that can be seen. Your Unity loader.js does everything here. Okay. So it deflates everything into something that looks like that, right? And really, at the end of the day, that's it. I mean, it wraps up your Unity, it converts it into a build that's compatible with HTML, and you're good to go. Okay, back to this for a second. So we built this, just to recap. So we did the tile mapping. You guys should know the basics of doing that. So again, your project is due tomorrow, your individual assignment. So again, if you want to make your level kind of interesting, my expectations is that it has a beginning and an end, right? There should be some kind of end goal to the level. That might be good. If you're in a group that's making a platformer, and I don't think any of you guys are doing that, but there might be a group in the first section that's doing that, then the great thing about this is if each of you make a level and use the same assets, which I would allow, right? Then you can progress in your project, right? You can have different levels that you guys all made with the same assets, and you know, it might not be perfect because maybe some people have different implementation ideas, but at the end of the day, you can probably reuse some of that stuff to make your final project. Okay, just like you would, I gave you the ability to do that with your assignment number 1. If you're all doing some top-down shooter or something like that, everyone's doing a shooter, and you're doing 3 levels of a shooter, then same thing. You could have kind of combined to use some of that for assignment for your final project. So we did that. We talked about a couple ways, just to recap, of you know, some kind of detection, and also we changed our way of flipping around. So we were using the flip on the sprite renderer, and that's great for flipping the texture, but the problem with that is it doesn't flip the collider. The collider stays in place, which causes an issue. So we talked about that a little bit. We also talked about some best practices in terms of what happens when you want to climb a ramp. What do you do? And like I said, I probably would break the ramps down into their own layer where I can detect that I'm hitting a ramp, and I can change my the force that I'm using on my characters to an upward force or a downward force, depending on the ramp that I'm hitting. So if I have all the up ramps together, all the down ramps together. What about, does anyone ever conquer ladders? What do you do with ladders? Josh, you ever conquer ladders?
Sorry?
Ladders on a platformer. What do you do?
What, to make a ladder object function?
Hmm?
Well, essentially, you probably have a rule to see if you're touching a ladder, and if you are, then it would just move you up.
Could, but what if you wanted to go past it, right? So you'd have to have you have to move up on the ladder. So you have to be close to the ladder, touching it, and then press up.
Yeah, so essentially it would take into account your input, right?
Right.
Because if I'm still pushing the button to move in the same direction I'm moving, then it would go on the ladder. But if I press the up button, for example, it will go, oh, okay, there's a ladder. You go up the ladder.
Okay, and how about if you're on the ladder and you want to jump off? Can you do it?
Well, yeah, you just press one of the sideways buttons,
right?
and it will cause you to jump
So I'm
off.
saying, so these are all things you have to program. So ladder is like a lot of little things to program to make the ladder work, right? Up and
It's got
down
a lot of
movement.
mechanics.
Tons.
Doesn't sound like it, but it actually does when
If
you
you're-
think about it.
Exactly. If you're going up and down the level also, when you're on the ladder, here's the other thing. You're on the ladder and you're physically on the ladder. You only can go up and down on the ladder, right? Unless you choose to go off. But what if you're passing through floors? And each of the floor there's a collider normally for you, but not when you're on the ladder. Like there's like stuff you gotta turn off and turn on and stuff. There's like things to do. And it takes a lot of Q&A, a lot of stuff that you're going to go through, a lot of testing to make sure that you're like, hey, is this working properly? And sometimes you'll, again, solve one problem and create another one. So ladders are tricky, ramps are tricky, water effects are tricky. I've seen some really cool water effects where, you do things with, water, lighting. What if I wanted to add lighting here? I mean, right now it's kind of like unlit. The scene is unlit. Could I add lights? Could I add shadows? Right now, no, because in reality what's happening is you have this. It's all flat, right? So there is nothing to receive shadows, really, at the end of the day, right? I mean, if you added a light, what would it do? But in the new version of Unity, there is ways of casting shadows on 2D objects, right, to create an effect. And we'll talk about those things. And particle effects. Particle effects is another thing. You can use particle effects instead of explosions, for your stuff. So lots of little things that you can do that we're going to be talking about next week. Starting off next week, we're going to be moving to, first thing I want to do is talk about scriptable objects. So one of the things we did with the player, inside of his scripts, we have something called the hero anim state. Hero anim state is different things, right? We have, one day when this loads, idle, walk, and jump. And when we're idle, walking, or jumping, different things happen. For example, when we're jumping, we make a jump sound and so on. Sure, we can use, enumerations like this, but we can also use something called scriptable objects. And what scriptable objects are classes that do not derive from mono behavior, but something called scriptable objects. They cannot be added to game objects, but they can be referenced, right? And they save their data. So remember that saving and loading problem we had? We wanted to save our score from one level to the other. Scriptable objects solves this problem. If you want to have a whole pile of settings from one level to the other, scriptable objects helps us with that, right? So we're going to talk about how to make that stuff and how to use them, because I think they give us more functionality. All right, so that's all coming next week, and it's from here on in. It's all special stuff, special effects, that kind of thing. Near the end of semester, what I'm going to try and do is give you guys an intro to 3D, right? So pretty much second last week or something, we'll do an intro to 3D. We'll talk about 3D controllers and all that kind of stuff. It'll lead you into game programming too. Hopefully you'll get more of that. And in game programming too, it's all 3D. It should be all 3D, all pathfinding, AI, all that kind of stuff, all the really cool and interesting stuff that you can do for the most part. Okay, so next week again, more of this, more of the same, but we're gonna kind of solidify our first playable build for our little platform, and then we'll go from there. Any questions around what we're doing today? Remember, next week is week 9. By week 10, you have another release that's due. Okay, week 10. And then finally, we're going to be one on week 13 and one on week 14. Week 14 is going to be our final presentation. It's going to take the place of your exam. So there is no final exam in this course, like we said. Okay? Guys, thank you so much for sticking around, and we'll see you next week.